Hi everyone, welcome to our 6th training video. In this video we're going to cover how you can download and run the Adib Robotics robot controller on a Windows operating system. Our setup is a Nuke mini PC running Windows 11 off an external solid-state drive. The reason I'm doing so is because I have Linux on my Nuke PC. The Windows operating system is also configured for real-time settings. There's a link on a Microsoft website that covers how you can configure Windows for IoT for real-time. I'll put a link for that in the description as well. The reason I couldn't use my laptop running Windows 11 for the robot controller is because the robot controller does some AI with vision, and that's a bit expensive. So this Nuke has 12 CPU cores as opposed to my laptop, which has 6 CPU cores. So this Nuke is more powerful for running the robot controller. Okay, so let's get started. We're back on the Adib Robotics website. I'm going to go to the downloads page, and under Adib Robotics controller you have the 2-hour free trial version for Windows. I'm going to download that. I already have it downloaded, so I won't wait for it. It takes a couple of minutes. I'm going to extract the folder, and I'm going to open the folder with Visual Studio Code. So the Windows install has quite a few DLL dependencies that come with the program. This is the actual program, and there's a README that explains how to do how to run. There's a folder for the ESI files. There's the Python sample Python code and the sample config files. So I'm going to open the Pack Expo demo. That's the Python script that we've been running. This is the same as the videos on Linux and Mac OS. This is the Delta config file. So I'm going to launch a terminal to verify. So if I try to run with the wrong Ethernet interface adapter name, it's going to prompt me to update it. So I'm going to pass it the Delta config, which is the config we've been using. So as you could see here, it tells me to use the one of these. I know that it's actually this Ethernet adapter. So I'm going to set it to this one. On Windows, we actually don't use the adapter names that are provided by ipconfig because they're not very descriptive. They're very ambiguous. So we actually use the names that the library provides. So if you're not sure what the adapter name, you could just run with anything, and then it will tell you which ones to use. I'm going to close Visual Studio because it takes up some memory. I want to reduce the CPU load so I don't get runtime errors. Because Windows, although this Windows OS is configured for IoT and for real-time, it's still not the best real-time operating system that you could use. Going to enter the downloads folder and the install folder. Going to launch the controller with the Delta config file. And because it told me what the interface MAC is, it means that it found the interface and it's running. Here I'm going to enter the Python scripts folder, and I'm going to launch the Python Pack Expo demo script as such. So now we should start seeing the motor turning. So right now it's moving as though there's a robot, but there's no robot. I'm going to stop it. And I'm going to change the gear ratio to 1. That way we will get motion as though it's a joint, a motor joint on the robot. I'm going to reset my servo drive so that the position goes back to 0, because now the position may be outside the joint limits. I've configured this encoder as an incremental encoder just for ease of use, so the position will automatically go back to 0. I'm going to relaunch the server and rerun the demo. So it gave me that the position is outside the limits, probably because the combination of offsets within the config file generated a position that's outside the limits. If you just change the encoder offset position to 0, on an actual system you want to be very careful setting this because that's where your robot 0 is, and if it's wrong your robot could crash. But I'm just going to set it to 0, that way I know the position is starting from 0. So now you can see the robot, the motor shaft is turning, but far less than before because the gear ratio is 1, so the motor shaft is turning just as much as the joint, the robot joint would be turning. This concludes this tutorial. Thank you all for watching, and in our next video we'll be going into some more detail about the APIs for the robot control software. So stay tuned, and we'll see you next time. Thank you. Bye.